Let us quickly go through the theory part of the Fourier series. The Fourier series is an infinite series representation of a periodic function in terms of trigonometric functions sine and cosine. You already know what is a periodic function which repeats itself at regular intervals. And a non-periodic function is the one which does not, like the step function. The unit step function is a non-periodic function. Periodic functions are like sine and cosine curves, right? These are a few formulae that you need to take a note of. We'll be using them extensively throughout our chapter. So f of x is equal to a naught plus summation of n is equal to x up to infinity a n cos n pi x by l plus b n sin n pi x by l. We have two cases, so this is basically the standard form of the Fourier series. Case 1 is where x lies between L and minus L. So a naught will be equal to 1 by 2L. Definite integration of minus L to L, f of x dx. An is equal to 1 by L. Summation of, definite integration of minus L to L, f of x cos n pi x by L. Bn is equal to 1 by L. Definite integration of minus L to L, f of x sin n pi x by L. Now case 2 is where x lies between pi and minus pi. So the only difference between the formulae will be a change in the definite integral. From minus L to L, it will become minus pi to pi. And in certain questions, they will change the limits. Accordingly, you will change it in your answers as well, right? And then we have the Euler's theorem. So the Euler's theorem, let f of x be a periodic function with a period 2 pi, which is defined in the interval alpha plus 2 pi, right? This is alpha is nothing but an arbitrary constant. And how do we define the Fourier series for a Euler's theorem? F of x is the same thing as before, is equal to a naught plus summation of n is equal to 1. This is the only difference. In Euler's theorem, n is equal to 1 up to infinity a n cos n nx plus sigma summation of n is equal to 1 up to infinity b n sin nx, where a naught is equal to 1 by pi definite integral of alpha to alpha plus 2 pi f of x dx. A n is equal to 1 by pi definite integral of alpha to alpha plus 2 pi f of x cos n x dx. Bn is equal to 1 by pi definite integral of alpha to alpha plus 2 pi f of x sin nx dx. So using the formulae that we have studied before, we'll be taking 4 questions which will help clear the concepts and help us know how to implement those formulae in our questions. So first we have, find the Fourier series of f of x where f of x is equal to 0 when x lies in the interval 0 and minus pi. And when it lies between 0 and pi, it becomes x squared. So the Fourier series according to the Euler's theorem is given by f of x is equal to a naught by 2 plus summation of n is equal to 1 to infinity a n cos nx plus b n sin nx. And these are the formulae that we have already studied before. We are just noting it down. Then we write a naught is equal to 1 by pi definite integral minus pi to pi f of x dx is equal to 1 by pi. We'll be splitting the intervals at 0th position because there is when the behavior changes. So to 0 to pi x square. So in the interval minus pi to 0, we have f of x becomes 0, and in the interval 0 to pi, we have x square as f of x. Right, we'll further evaluate this integral. Anything multiplied by 0, we'll get a 0. And then we have 1 by pi. We will evaluate this definite integral with this formula. That's nothing but integration of x power n is equal to x power n plus 1 divided by n plus 1. Right, so that gives us x cubed divided by 3. Right, and we have our limits 0 to pi. When we substitute it, we get pi cube minus 0 divided by 3. finally we get pi square. We get pi square by 3. That will be nothing but your a naught. So what does your a naught come out to be? It is pi square by 3. So now let us find an. This is the formula. We'll again be splitting the intervals from minus pi to 0. F of x cos nx dx. This f of x is nothing but equal to 0. Okay? Plus 1 by pi, definite integral of 0 to pi. What will this f of x be? X square cos nx dx. Right? Anything multiplied by 0 is nothing but 0. Plus 1 by pi. We will be using the UV rule for this. Right? What is that? Integral of u into v is equal to u into integral of v minus integral of u dash into v. Yes, this you would have studied in your 12th grade. So we will be using the Euler rule. That is nothing but integer, logarithmic, algebraic, trigonometric and exponential. Accordingly, this is nothing but your algebraic form and this is your trigonometric form. So this will be your u and this will be your v. Following which you will evaluate it the same way. And what will you get? We'll get x square sine nx by n minus 2x into minus cos nx by n square. And also we'll be having a plus 2 into minus sine nx by n cube. We will put the limits from 0 to pi. This entire thing is one bracket. Okay? Followed by which you will be submitting the you'll be substituting the limits and you will be getting an to be 1 by pi, 2 pi by n square, cos n pi. Cos n pi is equal to minus 1 par n, right? So that's nothing but pi and pi gets cancelled. So it's 2n square, 2 by n square into 1 minus 1 by n. So an comes out to be 2 by n square into minus 1 par n. Now we'll be finding out bn. This is the formula. And again we'll be splitting the intervals. So from minus pi to pi we have 0. We'll just put as 0 from now itself. Then we have minus 1 divided by pi. In the interval 0 to pi, it is nothing but x square. 0 to pi, we have x square sin x nx dx. Okay? Over here also we'll be using the Euler rule to evaluate. So over here we'll have x square as u and v will be our sin nx according to the Euler rule, right? Following which you will be doing the integral of v and differentiation of u, and on further substituting, you will be getting minus 2x cos nx by n, and on further integrating it you'll again be getting the integral of x cos nx. You'll be applying Euler rule again, followed by which you will be getting this. Okay? And finally, after substituting your limits, bn will come out to be 1 by pi minus pi square by n cos n pi plus 2 by n cube cos n pi minus 1. Be very careful while doing the integrations. It is a very lengthy and tedious process, but you can't help it. Then when we open up the brackets, pi and pi gets cancelled, so it becomes minus pi by n into minus 1 power n plus 2 divided by pi n cube. Cos n pi is nothing but minus 1 power n minus 1. So we have got our a naught, an and bn. So now we have our Fourier series formula for the Euler's theorem as well. All we need to do now is to substitute all the values that we have got into the main equation. So from there we get pi square by 3. 3 2s are 6, so we'll just write it directly. Plus summation of n is equal to 1. So after substituting an and bn, we get this. It's just directly substituting whatever we have found in this equation, nothing else. No further evaluation is required. Okay, and please to make a note, while teaching the formulae for the Euler's theorem, I had missed out on the 2. I sincerely apologize for that. So on this page that we had seen the formulae, it is nothing but a naught by 2. So please do make that small correction. So let us take another question. Obtain the Fourier series expansion of f of x is equal to e power ax in the interval 0 and 2 pi. So a naught is equal to 1 by pi, a definite integral of 0 to 2 pi f of x dx. That's equal to 1 by pi, 0 to 2 pi. What is f of x? E power ax dx. Integration of e power ax is nothing but e power ax divided by a, 0 to 2 pi, and we have the pi, right? When we substitute the limits, a naught comes out to be e power 2ax, 2a pi minus 1 divided by pi, and we also have the a. Right, now we'll be solving an. So an is equal to 1 by pi, 0 to 2 pi f of x cos nx dx. So we substitute f of x to be e power ax, followed by which we continue the integration. 1 by pi. There is a direct formula to this, which you can make a note of. So integral of e power ax cos bx dx is equal to e power ax into a cos bx plus b sin bx divided by a square plus b square. So when we compare this formula to our given equation, n is nothing but our b. So it'll be 1 by pi e power ax into a cos nx plus n sin nx divided by a square plus n square to the limits 0 to 2 pi, followed by which when we substitute the limits, we get 1 by pi into 1 divided by a square plus n square into, when we substitute 2 pi, it becomes a e power 2a pi cos 2n pi. And when we substitute the 0, it's nothing but e power 0 dot cos 0, and sin 0 is nothing but 0, right? And cos 0 is equal to 1. E power 0 is equal to 1. So 1 by pi into a square plus n square. In the numerator, we have a into e power 2a pi cos 2n pi minus 1. Cos 2n pi is nothing but equal to 1. So then it becomes 1 by pi into a square plus n square into, in the numerator we have e power a into e power 2a pi minus 1. So this will be our an, right? Then we'll move on to bn. Bn is equal to 1 by pi, definite integral of 0 to 2 pi, e power ax sin nx dx. We also have a formula for this. Please make a note. Definite integral of e power ax sin x dx is equal to e power ax into a sine bx minus b cos bx divided by a square plus b square. So now when we compare these two, our formulae with the equation which is given to us, we can see that b is equal to n and a is equal to a, right? So when we substitute it, we get 1 by pi into e power ax into a sine nx minus n cos nx divided by a square plus n square. We're just substituting this one over here, okay? And then we have our limits from 0 to 2 pi. So now on substituting the limits, sine 2n pi will be equal to 0, right? Any even multiples of pi in the sine curve will be 0, as well as sine 0 will also be 0. So this term virtually does not exist. Okay? So don't even need to put that as a step. So finally we get bn is equal to 1 by pi n divided by a square plus n square into minus e power 2a pi cos 2n pi plus 1. Now cos 2n pi, what will that be? That is nothing but equal to 1, right? So finally, bn comes out to be n divided by pi into a square plus n square into 1 minus e power 2a pi. Okay? Following which now we again take the Fourier series expression and we substitute all the values that we have found till now in this equation, and that's all. So finally we'll get f of x is equal to e power 2a pi minus 1 divided by pi into 1 by 2a plus summation of n is equal to 1 to infinity 1 divided by a square plus n square into 1 into minus n sine nx plus a into e power 2a pi minus 1 divided by pi into sigma n is equal to 1 to infinity cos nx divided by a square plus n square. So basically we are just substituting all these values in this equation. That's it. And if you want to do a little bit of grouping here and there, that's also fine, but you can just keep it as it is as well. No problem. Let us now solve question number 4 under Euler's theorem. If f of x is equal to x in the interval minus pi by 2 to pi by 2 and f of x is equal to 0 in interval pi by 2 to 3 pi by 2, find the Fourier series of f of x and deduce that pi square by 8 is equal to summation of n is equal to 1 to infinity 1 divided by 2n minus 1 the whole square. This is a very important type of question, very frequently asked in our papers. So first we'll be converting the question in a format which is pleasing to the eye. That's nothing but f of x is equal to x in the interval pi by 2 minus pi by 2 to pi by 2, and it is 0 when the interval is when x lies between 3 pi by 2 and pi by 2. What are the outer limits? It's nothing but minus pi by 2 is the lower limit and the upper limit is 3 pi by 2, right? It's breaking at pi by 2. We know that a naught is equal to 1 by pi. Definite integral of the lower limit and the upper limit, that's nothing but minus pi by 2 to 3 pi by 2 f of x dx. Now like we have done before, 1 by pi, we'll be splitting the interval at pi by 2. F of x is equal to 0 between minus pi by 2 to pi by 2, sorry, it is x dx plus 1 by pi from pi by 2 to 3 pi by 2, it is 0 dx, right? So this becomes 0. X's integration is nothing but x square by 2. So we get x square by 2, lower limit pi minus pi by 2 to pi by 2. On substituting, we'll get 1 by 2 into pi square by 4 minus pi square by 4. It will get cancelled, so it becomes 0. Anything multiplied by 0 is 0. So a naught is equal to 0. Now we'll find an. An is equal to 1 by pi. We have the lower limit and the upper limit like last time, f of x cos nx dx. We split the interval at pi by 2 and we substitute the value of f of x as x in the interval minus pi by 2 to pi by 2 and 0 in the interval pi by 2 and 3 pi by 2. This term becomes 0, followed by which we further evaluate the integral. So we get 1 by pi into x sine nx by n plus 1 by n cos nx divided by n with the intervals minus pi by 2 to pi by 2. Right? After substituting, all the terms will get cancelled and we'll get the final answer as 0. So our an is equal to 0. Next we have bn is equal to 1 by pi, the same formula, minus pi by 2 to 3 pi by 2 f of x sine nx dx. Then we split it at 3 by 2, put the f of x's value. This term will be equal to 0. On further evaluating this term, bn comes out to be 1 by pi into x cos x into minus cos nx by n plus 1 by n pi sine nx by n from minus pi by 2 to pi by 2. On substituting the limits, finally we get bn to be minus 1 by n into cos n pi by 2 plus 2 divided by n square pi sine n pi by 2. So now we have the a0, an and bn's value. We again substitute back in the Fourier equation. This term becomes 0. This term becomes 0. A0 is equal to 0. An is equal to 0. That's why. And we substitute bn's value over here. And we get f of x is equal to summation of n is equal to 1 to infinity minus cos n pi by 2 by n plus 2 divided by n square pi sine pi by 2 into sine nx. So till this part, it is the same thing as we have done before. So till now we have found the Fourier series of f of x. Now we need to deduce that pi square by 8 is equal to summation of n is equal to 1 to infinity 1 divided by 2n minus 1 the whole square. So for this part, we need to check the behavior of f of x, the function, at the point of discontinuity. What is the point of discontinuity? It is pi by 2. Hence at x is equal to pi by 2, f of pi by 2 is equal to 1 by 2, f of pi by 2 minus 0 plus f of pi by 2 plus 0. On further evaluation, it is half into pi by 2 plus 0. That's nothing but pi by 4. So your function f of pi by 2 is equal to pi by 4. This one we will keep it aside. Right? And now we will again substitute the point of discontinuity in the Fourier series that we have obtained over here. Okay? So we get pi by 4 is equal to f of pi by 2 is equal to summation of n is equal to 1 to infinity minus cos by n into n pi by 2 plus 2 divided by n square pi into sine n pi by 2 into sine n pi by 2. Okay? That is again equal to summation of n is equal to 1 to infinity. This term will be equal to 0 and then n gets, this term will be equal to 0 and we'll get 2 divided by 2n minus 1 the whole square pi into sine n pi is nothing but minus 1 power 2n. So finally, we get pi square by 8 is equal to summation of 1 divided by 2 minus 1 the whole square, n is equal to 1 to infinity.